but it's just showing you. So on the 3D model, it's colored by the static pressure coefficient. So the reds and oranges being the higher pressures, and you can see the stagnation on the nose of the car, on the wing as well. You can see the stagnation lines on the elements. And what you're seeing on this slice that keeps going along the length of the car is the total pressure sweep. So if I just let that come back to the start, what we can see, if I just pause it here, is we get things such as the Y250 vortex that's set up. So you can see it has this ball of loss that sits, because of that core being quite lossy in the middle of the vortex. And you can see that there quite nicely in these plots. And then you can just see the front tire wake forming, and as it evolves downstream, it tends to propagate. And you can see now, because the bodywork and generally the F1 car in itself is of a lower pressure, we can see that unfortunately its body weight's just starting to get encouraged down towards the F1 car. And as we go further rearwards, what we begin to see is that, yes, some of those losses have dissipated, but it's all getting drawn into that rear quarter of the car. And these are things that, as I say, as aerodynamicists, we're constantly trying to control and trying to mitigate against. But yes, such as the dominance of the wake in the flow field, it's a real battle that we've got on our hands there.